Okay, we're going to solve this problem digitally with GeoGebra. We have a spherical balloon. This gives us the radius formula as a function of volume, and of course the volume as a function of time. So we're going to start by putting in both of those functions. So the volume is going to be 10 plus 20t, but I will write x because GeoGebra recognizes x as a variable. And then I'm going to rename it as volume, or as V for volume. And then we have that line there. I actually had already scrolled this, so I should unscroll it for y'all. Back to kind of where we were. This is not my first time making this video. That is why it was already scrolled. Okay. So you get this nice line here, and that is your volume as a function of time. And then we're going to go ahead and put in our radius equation, which is a function of volume. Again, we'll have to use x. So we'll do that. So we have cube root. And it took me a little while to figure out how to put a cube root in here, but Google is my friend. So 3x over 4 pi. I think we did that right. Okay, so now we have the radius function, and I will just rename that to r. And then we're going to go ahead and answer the first question on here that says provide a function that expresses a radius as a function of time. Okay, well, we have the volume and we have the radius. And the radius is actually a function of the volume, so we need to put the volume inside of the radius. So we're going to have the radius composed of the volume of time. And then we have our new formula right there. So that is this, I don't even know, orangish, tannish colored one right here. We're going to just maybe unmark these, so get some of that out of the way. Kind of see here. We really don't care about negative values, not important. Let's see what the next question says. Find the radius of the balloon after 60 seconds. Well, seconds is our x value, so we're going to make a point 60 and then f of 60. How many of these stinking things do I have on here? There we go. Okay. And you can't see it because 60 is way past our screen here. So we're going to scroll so we can see where 60 is right here. And then I'm going to scroll my y-axis as well. And I scrolled too much on my x-axis. Come on. It's got a little bit of a leg in here, so I guess not being too impatient would be a good thing. Okay, so this is the point here where after 60 seconds, our radius of the balloon is going to be about 6.61, given by this point. The last question says that the balloon will pop if it reaches a radius of 10 inches. So at what time will it pop? Well, here's our 10 inches, and it might take a little bit more scrolling to figure out, oh, there, it hits somewhere around here, around this point. Well, in order to find that, we need to use the intersection tool. So right here, under this point, we could intersect, and we're going to want to draw a horizontal line at y equals 10, and then we're going to intersect that point or both lines at this point here. I have no idea what I just did there. There we go. I got it finally. So I had to click intersect, then tap on each of these lines. So I just had to make the line first, the horizontal line first. So now I have the point B where it intersects. That way I know that it is at a radius of 10. And right here, you can see then how many seconds it takes before this spherical balloon will pop. So about 209 seconds. And I think that's it. Yep. So after 10 inches, the balloon pops. So this is actually no longer valid over here. But this is basically how we use GeoGebra, and this was a very first experience for me to really teach on it. So hopefully I get better. Thanks.